that we can sing it faster, then you're wrong. But it'll help if you just sing along.
Bum, bum.
C-A-M-B-F-I-R-E-S-O-N-G song. C-A-M-B-F-I-R-E-S-O-N-G song. And if you don't think that we can sing it faster, then you're wrong. But it'll help if you just sing along. C-A-M-B-F-I-R-E-S-O-N-G song. Patrick!
Song! C-A-M-B-F-I-R-E-S-O-N-G.
Squidward! Good! It'll help if you just sing along. Oh yeah! I call this one the Campfire Song. Let's gather round the campfire and sing our campfire song. Our C-A-M-P-F-I-R-E-S-O-N-G song. And if you don't think that we can sing it faster, then you're wrong. But it'll help if you just sing along.
Bum, bum.
C-A-M-P-F-I-R-E-S-O-N-G song. C-A-M-P-F-I-R-E-S-O-N-G song. And if you don't think that we can sing it faster, then you're wrong. But it'll help if you just sing along. C-A-M-P-F-I-R-E-S-O-N-G song. Patrick!
Song! C-A-M-P-F-I-R-E-S-O-N-G.
Squidward! Good! It'll help if you just sing along.
Alright. Cool.
Holy fucking shit, Andre.
Yeah, what happened?
I fixed the problem I was having.
Oh, okay, cool. So we're live.
Great.
Yep, awesome. Great. Let me just do something here. Is chat, not chat, the stream okay? Nothing's already effed up by the time I just, started switching the scenes here. Alright.
I would hope not.
Let me just list out some stuff. Well, conditionals. Conditionals! Alright, so anyway. Welcome to the stream. Hope everybody's okay. They didn't get a lot of damage this Friday. So, welcome. It's this Friday. Welcome to this Friday. Jason's staring at me creepingly behind the monitor. Or is his laptop there? You can tell by my voice I'm a little bit nervous from his look.
As you should be.
Jason, say it in the mic. Come on. Say it in the mic.
As you should be.
Oh, okay. Oh boy. There we go. Awesome. What do we got? Loops. Let's see what else. Anything else? Classes. Pie game. Let's do
Can
it.
you go over types real quick?
Huh? Oh, user input.
Variables.
Yeah, we're gonna do that with variables. Let's see. User input.
User input.
Yep. All right.
Yes.
7, 6, 6. That's 6. Wow. I can't count. All right. Anyway.
Counting is a little necessary.
All right. So let's print out our hello world. So this is how you talk.
Maybe I should be the one who buys the lapel mic. Cause
Yeah.
like this is a pain in the ass. I gotta say.
You gotta hold the mic to your face, and you're just like.
I keep forgetting that I have to hold the mic up to my face in order for anyone to hear what the fuck I'm saying, unless I scream so that they can hear it in your mic.
I mean, you can scream like a chimpanzee, and don't attract a sea bear.
It's slightly inconvenient.
Yeah. Okay, so what I just did, I just print hello world. That's what they teach you in every single programming language. It's like, oh, you're new to this language, here, just write this out. And it's like, then we teach you every single line that exists. In this case, fortunately, Python only has one line. This print, this function, what does it do? It's self-explanatory. It prints into this thing called the shell. The shell is like the terminal. That's where you see your output, essentially. Or you can do your math here. You can pretty much do the code here, and it'll act as a calculator, unless you want to make it do something else like print hello world. But don't do it like that, because you're going to get syntax error. Syntax error is pretty much the grammar of the language. Or, yeah, that's pretty much the universal definition for syntax. Here I am talking so fast because I'm thinking this is going to be some kind of speed run.
Andre's fucking
Tactic.
speedrunning this.
So here we go. Well, obviously you can't print out something simple like that because computers are stupid. You gotta put it as a string. What's a string? It's a series of characters. What's a character? It's what you write. There goes Jason picking up the mic. So hello string. I'm a string. Hey, no, you can't end it like that. So there you go. That's pretty much the syntax. You gotta print out something. There. What oh, see? Now it prints. It does the same thing as I do here, but it's better for you to do it here so that way you can actually treat it as a text editor and like, you know, do code and not have to worry about effing up that you miss a semicolon, which you don't have to worry about because Pythons don't support semicolons. So if I do this, it won't care. Oh wait, it does. Wow. Okay. I don't know what to say to that. That's surprising. So if I do 3 times 4, it also does 12. It not only does multiplication, it can do math. So if I do 6 divided by 3, it does 2.0. It gives me a float when it's supposed to be an integer. But I'll talk about that shortly. Let's see. How are we on the timer?
Is there time to read a donation?
Oh god, wow. All right, so we got print. Hi, my name is oops, my name is what? Hi, my name is who? My name is totally effed up Eminem's lyrics quickly. So how many print statements do I have there? I have 4. Wow. And what is that gonna do? If by the way, if you know, write your code here, right? And you go to this thing called run, you click on it and run module. It's gonna ask you to save or if it's okay that we're gonna save it, of course. And you can see you can do it here. Yeah, you can see all the results here what I printed out, so I didn't give much spoiler over here. Yeah, so now variables. So let's say wow, Jason's vigorously typing over there. Oh gosh, I don't know if that picked it up. Here we go. Wow, I'm like screaming in the mic saying So we got variables. What are variables? I don't know. It's those symbols, those crazy symbols you see like X, Y, U, A. And then you got like, I don't know, this symbol that you just decide to use as opposed to an X.
Except that you're not allowed to use that because, you
Yeah,
know, Python doesn't let you do that shit.
Yeah, it's reserved. So we can say Python, Andre, you know, you get it. So you see equations like, X plus 2 is equal to 4.
That's not okay.
What is X? Obviously it's 2.
But that's not okay.
Yeah.
Because Python doesn't do that.
Yeah,
shit,
it doesn't.
So don't do that.
Yeah. So if we do, let's say X plus 3, not plus 3. If X is, we're gonna make a variable. It's gonna be a number. Hopefully, you know, 3 is a number. Y is also 5. And if we say like X, let's print out X times Y. And yes, you can do this. You don't have to do strings. Print can pretty much print out anything, just like a printer. So if I just press Control 5, which is like a shortcut to run the module, I get 15. I had to double check that because I didn't remember the numbers.
Did you say Control 5?
Control F5. I apologize.
Very important.
Yeah, it's very important to know your Fs and your 5s correctly. And then you get a plot twist. Z is 10. Oh my gosh! Wow, freaking Z shows up, and like you see X, or no, hold on, I apologize. X times Y minus 10. Wow. I apologize. I'm not even using the variable correctly there. So it's going to say x is equal to 3, y is 5. So we got 3 variables, and then we added the third one, which is z, 10. The first print statement is going to print out 15 like you saw in the previous run. And then you get x, you get the same thing but minus z. So I hope I know my math. 15 minus 10 is equal to the determinant of a 3 by 3 matrix, which is 5. Hopefully I didn't scare you with the determinant part. What else? Not only can it store number, it can store strings. I'm not gonna sell this. So let's say word. Sup dog? Wow. You don't like when you quote something. You don't use a colon. Use a double quotation mark like you do in like when you write a story. You get sup dog, and you know you want to print out that word. It's like, yo, what up? And you know, then you run it. And what do you get? Sup dog. That's right. And not only does it do strings, it can be, you know, floats. So we got I don't know, pi is equal to 3.14159. Andre, you're such a nerd. How do you know like the first 5 digits after the decimal? Get used to it. I'm a college student, and apparently all my life I've been using up to 3.14. But you know, it did the same procedure correctly on this one physics question. But you know, it took me 3 emails and like a day to realize that the teacher used the whole like 14159. So that's why I got the question wrong, which was annoying. And we want to add it to another number. So let's say number is 21. That's like how old I am. So we got number. No, we get the sum. Oh wait, we can't do sum because that's highlighted. And when you see something highlighted, Python is like, that's my word. And be like, whoa, back off, man. And then you got total. You get number plus pi. What do you get? I don't know. Is it 24.14159? Maybe. Let's see. And the result is 24.14159. I probably mispronounced that or missaid that. That's okay. I'm a programmer. I don't know. Okay, that was too pretentious there. Too selfish. My bad. Let's see. So what do we do when we so okay, here's the difference between float and integer. As you can see, integer has no decimal, float has a decimal. So as you can see with pi, as we all grew up since, you know, like 4th grade, we all know that pi was like 3 point something. And there's mathematicians nowadays that are still trying to figure out the end of pi. They are my heroes. Anyway, let's see, what else? So let's say word is like, yo man,
Perfect.
Yo man, how old are you? And he's like, sup, nothing much, man. And for some reason it's just like, why? So we can do it like this, where it's like, okay, well, we're gonna print out word, right? And then we're gonna print out number. Let's say I'm 21, which I won't be. And he's gonna be, yo, main, how old are you? And be like, well, just 21. I mean, I don't know. That's a way to respond to that. How to cast, or this is a special word, casting. Oh boy. Like, let's see here. Jason's over here pondering about like, how's everything going on. Here comes my roommate coming out. He can probably give me an example. So yeah, help me out here. So yep, that's right. So let's say we got Babylon number, right? Babylon, I don't remember how to spell it, and it's 22/7, right? Which is exactly 3.4159. You're looking at me like I'm wrong. Am I wrong? Huh? It's 3.14159. Oh, okay. Well, frick. And so and we say, yeah, okay, I got an idea. So it's like, so question, we're going to make a variable called question, and it's going to be a string. It's going to be like, yo, what's pi? And that, tell me pi.
42.
Tell me what pi is. And I'm just here like, response. Pi is, now I want to put response in the same, I want to combine response and Babylon, but obviously Babylon, as you can see, it's a expression here. We got 22 over 7. I can't just say pi is a number. The program won't like that. They're gonna be like, why are you combining letters with numbers? Are you stupid? He'd be like, look, I don't know. I don't know my numbers and characters. So what I do is like, okay, here, let me put response plus, which combines two things. I wonder what gave it away. And you got this special keyword that says string, and as you can see there is like, I'm supposed to put something between those parentheses. It's asking for an object. I don't know what the object is. Let's just say 22 over 7, or Babylon in this case. I'll make it as my object to put in. This is going to be my parameter. And what's it going to do is going to convert that 22 over 7 into a string, something that response can understand, or pretty much this whole string can understand. So if I were to, you know, let's ask the question. So we got question, right? And then we give it a response, right? So it's not going to bark at me. Yeah, wow, wow, I was off. What the heck? I thought it's going to be 3.14159.
No, it's only accurate to 2 digits.
Oh, well, frick.
22 over 7 is a really bad approximation of pi.
Oh, okay, great. Let me say it in the mic. Say it in the mic. All right. But here, let me show you proof that not only I can make it work, I can make it wrong. Here, see? Wow, it says type error. Must be a string, not a float. So in other words, I gotta take this, which is a float, as you can see here, because this is not gonna be a whole number. It's not gonna have a decimal, or it's going to have a decimal. My bad. And you know, if I'm going to print that, if this is a string type and this is a float type, they don't match. It's like shoving a diamond into a triangle. You're half right. There you go. Awesome. I got approval from Jason.
Okay, now you should try using an int.
Okay, so we got int. Oh boy. So pi is so I'm going to do a double casting, right? And I'm going
No. You should just make it an int and not bother being pi.
Okay.
Or a bad approximation of pi, as it were.
Okay. All right. So Babylon Babylon. We're gonna have a random number. I'm gonna make it 34, right? And the switch costs like what, $300, and we're gonna say, yo, tell me how much that switch costs. No, how much it costs. And I'm gonna move this up. Gonna get rid of this. That way you guys can see. Don't do that. Awesome. Let's see. Python. Oh, the cost is. The total is. Okay, we ask the question, response, then we do an int, or actually, my bad. I'm sorry. Cast this. Make this a float. Float again is something with a decimal. I'm going to cast it to an int, which is going to not make it as a float, but it's going to turn it into a whole number. Yeah, a whole number, not a piece of number. And then there you go. I failed because I forgot to put it to a string. So I'm going to do double casting. So how this works, it's going to work from inside out. So what happens, it goes to switch cost, goes to int. It's going to be taking this 300.00. Welcome back, viewer N. Yep, nice to see you joining the Let's Switch. frick.
Yeah, the Twitch,
string.
yeah.
It's okay. And then I'm just speed running here. And then you got the int, right? So this int converts this switch cost into a whole number. That's right, not a piece number. And then it's going to cast this whole number into a string so it can satisfy this response. So that way, if I do this now, it's doing a double casting right now. So the outer part will be the last data type you're going to create out of the variable that you make there. Let's see. So yo, how much? Tell me how much it costs. The total is 300. Oh no way. Awesome. So user inputs. So what if I don't want to hard code numbers? I mean, I can do other things, right? I can be like, yo, input. Let's see how much. Here, I can do two things at the same time. So here, let me take this apart. I didn't use number for anything, so I apologize if that confused you. So let's say, let me ask a question. So, how many of us are streaming right now? Or how many are we? Yeah, that's the spirit right there. And then I want to say float. I want to cast this to a float, right? So we got to make sure we got matching parentheses. Why is it making that noise? So we got these two closing in. So we got these two parentheses. These two. Oh, I would get a syntax error. Yep, too many right parentheses. That's right. Thank you. Let's see. And we go and print out total. So what's going to happen is it's going to ask me to type in input. It's going to ask for my input, and see, as you can see there's that blinking cursor that we see everywhere. If you go and touch a computer, and how many are we? There's 2.5 men, right? So 2.5, and there we go. It prints out the total 2.5. And if we run this again, and I put in a different input, let's say there's a whole 3 people here, then it's going to turn it into a float. Oh wait, I'm sorry, I shouldn't put a dot, a period, and a zero. So if I just put in 5, it's going to give me that 0.0, thus proving that it converted my input into a float. So again, work inside out, takes in whatever, what is it, a string, converts it to a float, and then prints it out as a total. So in this case, how many are we? If I type in hot buns, you can't convert hot buns into a float because there's no way to convert a character. You can't convert an A to like an arbitrary number like 7. That's not how it works. There is a thing called,
unless it's an int.
Yeah. Oh, really? Oh, okay. Frick, man. All right, let me give it a shot then. So if I convert this to an int, I go and give it a try.
But it won't work with that, of course.
Yeah. So if I do it again with an int, I say my brioche buns, then it can't.
Gotta love brioche.
Yeah.
Good shit.
So keeping this user friendly. How are we doing with time? We're asking small donation for.
Jesus Christ.
Can you read off the donations? Well, it's going to take a while if I clear this up here. Conditionals. Oh, you know what I also forgot? Functions. There we go. So we're good. We're good on the variables. So I'm gonna put an X there to denote that we did it.
What about user input?
User input. One more example.
Oh, you did forget to do one thing. You didn't multiply a string by an integer.
Right. So if I were to say, let's see, boy, and I say, I'm gonna say, how many boys? Wait, no. I'm gonna say that boy. Meme is equal to that boy. And I say, okay, number. So I'm going to cast it to an int. I'm going to say input. I'm going to say, how many memes do you want? And you can say, I want the whole village, but that's too much. Be like, then you want to print out meme times number. What is this gonna do? It's gonna multiply the string that many times. So I put in 7. It's gonna spam that boy a lot. That's a lot of boys there. How about, what if I want a girl? Here, let me do it this way. Here, a girl.
Yeah, there you go.
And if I do this again, and let the girls, outpopulate the boys. So we got girls, right? So we got 9 girls. There we go. Awesome. I always wanted 9 daughters. Anyway, and then if you take this and cast it to a string here, you're not going to get 7 boys and 9 girls. What you're going to get is mighty number that girl 7. So that's a great example there. So we're off with that. Conditionals, awesome. Next, let's see, conditionals. If you reach a stoplight, then what do you do? You speed, of course. Thank you. Then you speed. I do not advocate you guys to actually speed. Please don't do this at home. Or I mean, out there. Then you stop. Okay, so how do we convert this sentence into programming? You got a keyword called if statement. Keyword refers to like what's reserved for that programming language. So it's like, you go out there into the world, and there's gonna be like a certain word that's gonna be like, oh man, that is so dank, and then Americans will be like, hey, that's my word. I apologize for that. Wow, I am so sorry. Okay, let me make a moment of silence.
Keep going.
Yeah, so stoplight is equal to that anyway, and you reaching a light and you say, oh, you stop. All right, cool. You stop, right? And why? Wait. Okay, we don't need curly braces. I apologize. And you need this. So this is a syntax. You put the condition here, right? Here, let me write the story here. So you oh wait, no, I'm going to do it this way. So doing pound signs or comments, as you may have noticed, like it didn't do anything in the previous run. It doesn't, these lines of code, they didn't affect anything that we did before. They're just there to be a secret to the compiler. So it's just like, you and me can understand each other. It's like, yeah, I understand what you wrote here in this code. You'd be like, yo Andre, look what I did. Look what I did over here. Look what I did over here. And I'll be like, yeah, I get you. And then the compiler is like, can I get some of that juicy gossip? And be like, no, this is a comment.
Did you just say compiler 3 consecutive times?
Oh, I'm sorry. And the interpreter. Yeah, Python is an interpreted language. It doesn't compile. There we go. All right, that's different, but let's go. So no worries. Here we go. So let's see. So we are given a situation that it's all caps, right? Yep. And you're given a situation, you reach at a stoplight, what do? Then you stop, right? So this is how I convert it to conditional statement. So we got you stop. Great, because you know why? Because it's true. It's true that the stoplight, okay, well maybe frick. I should have made it more relatable. It's a red light. I apologize for that. Let's see here. So we got red light. Red light is equal to true. Is it true that this red light is red? Yes, we're going to say it's true. Then you go inside this statement and you say you stop. Else if, else, or else, self-explanatory. Or here, let me add into the story here. So, else, otherwise, actually is what you would usually see here. So let me put that in parentheses there. Otherwise, you continue driving. So this is the syntax for it. So here we go. It's pretty much the keyword, and the colon, you don't need to put a condition like you see with the if statement. So if this red light is true, there is a red light, then you stop. If not, then you keep going. You drive. You drive. You drive. Come on. You drive. You continue driving. Please. All right. Diving, not diving. And so we're going to run this again. Oh, I forgot my parentheses. Thank you. Thank you, Jason, for saying that telepathically to my head. So here we go. Red light is true. You stop. It didn't run this code. Why? Because it was a red light. Why would you keep driving? What are you? You really asking to donate money to the police force? You gonna like you want to get tickets or something? Come on, don't do that. All right, so let's change it up a bit. It's not a red light. Instead, it's not a red light. So that's pretty much logic that we have right now. So it's like red light is false. Therefore, it doesn't run this code. It runs the else statement here, because essentially the rule is if this condition is true, then you go through this code and you break out here. If it's false, then you don't run what's inside the if statement, and then you run inside the else statement here. But here's a plot twist, like M. Night Shyamalan twist. So what if red light? No. What if yellow light is a thing? No. Yeah, let's say red light is equal to yellow. No, we can't do that. So let's say yellow light. Right? And same thing. And what it is go and check to see first, is this true or false? If it's false, then go to this next line. If this is true, then run in here. If it's false, then run the else statement. So the else statement is pretty much like the last point in this whole series of condition statements that it's like you want to ask or something. So we're going to add in a new variable. We're going to say yellow light, and I'm going to say it's true, right? And so what we're going to do is it's not a red light, it's a yellow light. So what do you want? You want to go past it, or you want to speed, or you want to stop? Well, it's up to you. What? Speed or stop?
I think you should just shoot the light.
Shoot the light. All right, shoot the light. There we go. Awesome. So red light is false. Is this gonna run? No. Is this gonna run? Yellow light is true. Yes. So go in here. Go in this path. We're going to take this path. Like you go open up a book and you're like, oh boy, turn to page 20 to see if you get a, oh wait, that's not the right keyword. I apologize. The actual keyword, I'm sorry to lie to you guys. It's not else if, because Python doesn't know else if. It knows elif for some reason. It tries to make itself a meme, but it failed. So we're just going to run this again. So shoot the light, because again, this is false. It's not a red light. It is a yellow light. Then you shoot the light. So there we go. So we're going to mess around with the logic here. So what if I can make this both true and that I get rid of this else if statement here, right? Or else elif. So we have this, right? So this intersection light is going to be bad. It's going to make people crash into each other. So what's going to happen is since red light is equal to true, it's going to run this code. Since yellow light is equal to true, it's going to run this code also, because they're both if statements. They're not. This one is not an elif of that if statement anymore. So if I run the code now, I can't believe I didn't control F. not only do you stop, you shoot the light and you get in an accident. That's not good. So let's keep it this way. Let's keep it like this. Right. Anyway, else, awesome. Didn't do anything. You continue driving. Awesome. What if I want to combine this? What if I want to combine this as like, I don't know, like one variable. So let's say light change. So light, right? So I want to say this is green, right? And like, as opposed to using true false, which are actually, those are called booleans, special data type. So you got the float, you got the integer, you got the string, and you were introduced to boolean, and boolean will help you, you know, deal with the logic here, the logic gates. And so you got red light, yellow light, and LF, green light. Or wait, well, I mean, these should be lights. My bad. So we're going to say if light is equal to green, run this code. If light is equal to, oops, if it's equal to yellow, run that code. And if red light is equal to, I'm going completely from the bottom up. I don't know, I just decided to go that way, I guess. And so light is equal to red, and if it's equal to red, run, you stopped. If it's equal to yellow, run, shoot the light. If it's equal to green, you continue driving. All right, so what?
Note that you have to use double equals and not a single equal sign.
Yeah, so as you can see, I'm assigning green to the variable light. But what we're doing here, you see the double equal sign, that's like security, like, yo, like, we're going to put double equal sign there. Make sure they are equal to each other. If I were to replace this light with this value, because obviously that's what a variable is, it's like a placeholder, it holds that value. And if I just replace it with green, is green equal to red? Is green, red the same thing, color? No, it's not. So, I mean, obviously, I can show you evidence. This is red, this is green. And you got yellow, right? Is green equal to yellow? No, it's not. So you move on here. And make sure, also note, I also added in back the else if there. If light is equal to green, then you continue driving. If I replace this with green, will this be equal to green? Yes, because they're both the same thing. So if I were to run the module again, wow, I can't believe I didn't control F5 that. I forgot my colons because I don't know the language. Just like I was back in elementary school, I struggle with English. And there you go, you continue driving. All right, awesome. And if I change this to red, then oops, I have to make sure it's in a string. If I control F5 that again, awesome. And if I make this yellow, it's going to print out the last thing that we have there. Awesome, shoot the light, awesome. Okay, and there you have it. So also what we can do is, so let's say light is equal to, no, I think that's it for the lights. Or no, here. What I can also do here is not use else if. I can use just 3 if statements. And if I just say red or orange. Here, if I put in a random number, it's like, hey, let's have a new law where, city law, where we change the lights to be, well, we don't change it. We just add in a light. And we're going to call it orange. And we're going to be like, that's not a normal light color, street intersection light. There we go. I went a little too far there, but that's okay. So I make it orange. What is it gonna do? It's gonna be like that. It's gonna say, there we go. That's not a normal intersection light, because what happened is orange is not red, orange is not yellow, orange is not green. Well, I mean, it's a combination of red and yellow, right? So, but I mean, it doesn't.
Except if you put in red, I think you'll find your code doesn't work the way that you are saying it does.
All right. So if we do red, I'm just gonna see what Jason's talking about. And we got yo stop. That's not a normal intersection. Why? Because this is how it's being seen as. Like that. So we got one if statement there. they're like that. We got an if statement here. They're together like that. But we got this if statement here paired up with an else statement here. So what Jason was saying or trying to tell me is like, okay, well, it is a red light, so you stop. But like down here, as you can see, an else statement depends on an if statement. You can't just start your sentence like this. You can't be like, oh, otherwise, you know, you can't, you wouldn't, I don't know, you can't buy it. And then there's gonna be me, and I'm gonna be like, what are you talking about? What? So, special note, if there's an else statement, if there's an else part, it's going to be combined with the previous if statement. So if I were to,
if you want to make this work correctly, what would you do?
So if I were to do this correctly, let's see, else, if, then that's going to combine that. Here, I could do it like this, where light is equal to orange.
No, you should leave it as an else.
Alright. Fine. Jason's telling me to leave it as an else. You have the mic? No, you don't want to speak in the mic anymore? Alright. Alright. So we got light is equal to green. I could change the value of light here.
Or you could not do that.
So there are multiple ways to do this, but if you're given the constraints of like having to keep these else, if else grouping here, what's the rule here? We gotta make sure. Wait, and the value here has to be red or any color, actually. What do you want to do? What are you trying to say? You want to bypass it?
I'm trying to say that you should be teaching people about if else blocks.
If else blocks.
Yeah.
Okay. What? Okay, so.
Or not, or you could not do that.
Okay, well, so I'm giving if else.
Change yellow and green to elif.
Oh, duh. Thank you. Yeah, there we go. So, I don't know why that took me a bit. So, if you change yellow and light to be else if, it's going to run through this. It's going to say it's true, run through here. And since all these three conditions are grouped together underneath this one if statement, so it's saying, in other words, like, if it's a red light, stop, then stop, right? If yellow, if not, then it's yellow, so slow, or shoot the light. If not, again, wow, the M. Night Shyamalan plot twist, then it's green, so keep going. And even if not, well, in this case, it'd be like, otherwise, finally, our last thing, then, please, then it's not a normal light, you see. You encounter, oh, whatever, I'll just leave it like that. And then it's not a normal light. So that's what, if we translate this whole thing into English, then this is pretty much what we end up seeing or hearing, actually, from people. So, yeah. We're good with the conditionals.
I mean, you can run it to prove it.
Yeah, so if I do a different color here, so like, let's say I want to do green now, right? So, and there we go. You continue driving because it's not red. If it's not red, check to see if it's yellow. If it's not yellow, check to see if it's green. If it's not green, then check to the last statement, the else, the last resort. But in this case, since it's green, you continue driving.
So try purple.
So if we do purple, then that's not a normal color intersection light. So it's not red, it's not yellow, it's not green, then it's going to go to the last resort by default, or whatever your default response, and be like, okay, that's not normal. So I believe that's good. Also, we're going to do combinational logic, I guess. So here we are. So I'm going to pick a random ass number. Think of a number between 0 and 100. Awesome. So you got a number, right? And I'm gonna make this int for, you know, to make it simple. Pick a random number. How are we with the time? And we're gonna use what we learned from the previous section, conditionals, and we're gonna say if number. Not only can you check to see if it's true or not, you can check to see if it's greater than or less than, etc., etc. So we're going to check to see if it's greater than 50. If so, then, you know, we're going to print out it's greater than 50. That's such a boring response, but else if, elif, remember it's elif, not else if. They just combined it. I don't know why. Number is greater than 50 or 30. Here, let me. No. Here, no. I'll do it. I'll do it anyway. So number is number. Well, that's probably foreign for a number. If number is greater than 30, then wow. Wow, your number is bigger than 30. And then we do number is greater than 10. We're just going to jump down there. Forgot my colon up there. I'll fix it. And be like, wow, bigger than 10. So, or here, I'll just put greater than 10. You know, I should just be consistent with the prints. I'll just leave the middle part like that. So, if I run this code right now, right, and I say, give me 11, it's going to say it's greater than 10. If I run this code again, wow, this is going to be a bit. Oop. Alright, cool. If I say 23, it's going to say that it's greater than 10 again. Okay, I should have picked a bigger number. If I say 39, it's going to say, wow, your number is bigger than 30 and also greater than 10. So, like, if number is bigger than 30, which is 39, is bigger than 30, right? So it's going to read through here. Since this is an if statement, so it's like its own thing. Now, it's not an else if, it's not a print, it's not an else. So it's going to say, oh, we're going to go through here again. We're going to see if number is bigger than 10. Oh, it is. So we go through this code and say greater than 10. That's why we got both of those prints. So, and it didn't read this because it's, you know, not bigger than 50. So if I were to run this again, can you imagine if I say 69? Can we take a guess what 69 will do? It's going to print all three statements. Wow. It's going to say greater than 50 now. And then it has the same thing from the previous two. Why is it doing this? Maybe if I want to just print out one print statement. So what I do is I'm just going to do else if here, elif. I should start pronouncing as elif. And if I do it like now, so elif, pick a random number. If I do 79 now, and now it's going to print out one print statement. That's going to be greater than 50. Because this is true, it breaks out of this whole nest here, and I don't have an else statement, so that's fine. It just breaks out of there. And there you go. That's how you do that. I feel like I'm missing something. Yeah, right. So what if I want to say it's in a range, right? So let's say and number is less than 60, right? So here, I'm just going to do it like this. Now, wow, what's between 50 and 60? Oh, you know, well, in this case, it'll be 51, 52, 53, 54. Wow, I don't know my numbers. 54, 55, etc. Right? Wow, okay. And then it's going to be up to 59. The reason why is because we're saying number is greater than 50. If you remember from math class, you know, something greater than a number is not the same as that number. So if I want to include if that number is equal to 50, then I just add in an equal sign to that greater than, and then to this less than. So that way it can include the 50 in this range. So if this number is in that range, print this out. If not, then I'm just going to print out this else and say it's not in that range. How are we on the time?
You've been streaming for an hour and 2 minutes.
2 minutes? Okay, that's not bad. Oh wait, I'm an idiot. In different languages, you would use ampersands, but Python, they are so Pythonic, they use ands and ors. And I'm going to talk about ands and ors in a bit here. And here we go. So if I pick 55, it's greater than 50. Why does this work? Well, is it true that number is greater than or equal to 50? That's true. So yes. And if number is greater or less than or equal to 60, is that true? Yes. So here's like a little truth table here. So just keep this to your heart. Truth table. So for ands, here, let me actually do a multi-line comment so that way I don't keep putting hashtags in the beginning of every line. So you just need to put 3, so to make like a multi-line comment. So it's not going to be red, it's going to be green this time. This is actually a doc string that's for like writing a little note about your class, and notes if you need to refer to the code around it. Truth table. So we got ands. For ands, we got 2 conditions. We got C1, or let's say greater than equal to 50, and I'm going to just divide this up by a pipe and say less than 60, and I'm going to put result here. So, and let me also put a pipe. Awesome. Alright, so is it true that 55 is greater or equal to 50? True. So if I were to leave that as true, or I just denote as T, please remember that's true. Is it less than or equal to 60? Then yes, it's true. Then the result will be, it's a true statement. In other words, it will go through this line of code, or inside this if statement. So if it's greater than 50, but it's not less than 60, so if I were to put in 66, then it would be false, because it needs to be, both of those conditions need to be true to order to run. Well, actually, this is between 50 and, oh wow, that's not 50, between 50 and 60. Awesome. Let me run that code again. So if I were to say, in this case, 67 or 89, or oh, I got, oh, my bad, forgot to end the comment there, the multi-line comment. And if I were to put in 89, that's definitely not in the range. So is it greater than 50? That's true, but it's not less than 60, so it's false. It does not run that code, and it goes to the if statement. If I were to do the other way, if I were to flip those values and say it's not greater than 50, but it's less than 60, then it's false, right? So let's prove it. So if I were to put in like 21, it's not in that range, because 21 is not greater than 50. So there we go. And if it's not greater than 50 and it's not less than 60, then it will be false, because if I were to prove it, let's see, greater than or bigger than 50, less than 60, I don't know, let's put in like 2,000. So if I were to put 3,000, that's not in that range. It's, well, actually, how do I, frick, well, I mean, it's bigger than 50, but it's not less than 60. Do we have an example of that, actually? A number that's, no, never mind, it's not possible. So let's see, yeah, it'll be either greater than 50 or less than 60, no matter what number you put in there. But for future reference, so if both conditions are false, it's going to yield false. And we're going to talk about ors. So please keep this in your mind. I'm not going to scroll down for that. Truth table or. So if we're going to change this to or, and what it's going to say, what it pretty much is, it's going to say greater than this number. This number is greater than 50 or less than 60. And 60. So what we're going to do, we're going to run the code again, and we're going to say, oh, why did I delete that? Or, and this is going to be 60. Oh, and this is supposed to be 50. Here, let me make this to be 10 and 0. Different example, maybe shorter one, but not shorter one, an easier one to read. Forget about 50s, 60s. There we go. All right, so if this is true, oops, why is this auto's true? Oh, I also need to make a column for results. All right, oh frick, what the heck? Let me control, there we go. If either or is true, then it's true, because if number is greater than 0, or is this number less than 10, then run the middle code. So if I were to do this now, let's pick a number that satisfies both numbers. So if I put 5, it's, what, it didn't save? Oh wait, oh wow, oops, I was too busy thinking about 50s and 60s for some reason. So we just run this again, make it more relatable. This number is greater than 0 or less than 10. That's true. 5 is greater than 0 and it's less than 10. So let's see here. Let's say this is true and this is false, right? So wow, how to prove that actually? Oh, never mind. Duh, that's too easy. So if I put in 15, it's going to be greater than 0, but it's not going to be less than 10, but it still runs that line of code, this line of code in the if statement. So if I were to now do this backwards, so let's say it's not greater than 0, but it's less than 10, so we're thinking about a negative number here, right? So let's run this number, this code here. We're going to do -1, that's less than 0, and it's going to run this code again because this statement is true. So either you pick one or both of the conditions to satisfy. The only way to make this code not, or to make this print statement not appear here in the shell, you will have to find a way to make both of these false. So let's pick a number. Let's see, a number that is
less than 0 but greater than 10. That doesn't exist.
Yeah, so let me change it up a bit. So let's see, to make this true, let's say, we're just gonna make a range, a simple range. So like if it's, oh wait, frick,
just flip the greater than or equal sign code.
yeah. So right, so if I were to say, if I can find a number that's less than 0 but greater than 10, then run this line of code. So if I were to put in 5, what b? If I put a 2, then it's not in that range. It's not a negative number, and it's a number that's not greater than 10. So
Of course, no number will ever be that.
yeah, so you can't put in a number that will do that. All right, next, and that's ands or ors. Awesome. So great. We're good with conditionals now.
What about not equals?
Frick. I guess we're not done with that. All right. So let's say the total is 2 plus 2, right? And we say if total is equal to 4, then run this saying, wow, good job. God job. Good job. Else. That's incorrect. If I can spell print right, please. That's incorrect. Come on. Oh, please. Incorrect. Alright, so if we run this, we saw in last time with the lights, okay, if I can know my colons, also here. So, pick a random number. Alright, so I'm going to pick, wait, doesn't matter. Good job. So, what happened here is we got total, right? And total is equal to 2 plus 2. What is 2 plus 2? It's equal to 4. Here, I'll prove to you. So if I were to say 2 plus 2, it's going to print out 4. So total is 4. 4 is 4. Remember, the double equal sign means like you're making a comparison between the left and the right side of the equation there, or I mean like the operator. Yeah, operator. And so it's 4. Good job. But what if I put in an exclamation point? Oh wait, I'm sorry, that's not a thing in Python. Frick. That's in other languages. They do exclamation point equal sign. I'm going to do not. That's the keyword.
Python?
Really?
Yeah.
Exclamation point equal sign?
Yeah.
Okay, well this exclamation equal sign, please get used to it, because you can't just type in not in other languages.
Yeah.
Yeah, so it's better to get used to this convention.
The not is a literal negation.
Yeah, so so we run this code right now and say if total is not equal to 4, then that's incorrect. So what do we get? That's incorrect. So why? Because 4 is going to be saying 4 is not equal to 4. Wow, that sounds weird. That sounds weird. 4 is not equal to 4. So, if 4 is not equal to 4 for some reason, then that's incorrect. We negate the value here. Or, I mean, well, okay, actually, let me do it this way. This is much better. Switch. Let's switch over to this example. Alright, so we got true, right? We got switch. Lights are on, right? You got to get that night light to help you sleep, no matter how old you are. Light on. And then, let's say light off, right? So I think this is a much better example, actually. I don't know why I did that math equation. So if I do switch right now, and I'm going to say light on, because why? Because the switch is true, and since it's in an if statement, it's going to run through that if statement code. Lights are on, lights on. But if I were to make this exclamation point, I can do that, right? All right.
No.
Not.
That's where you use not.
Oh, okay. So if I use the keyword not right there, it's
You can
going to...
also use it like a function.
Huh?
You can also use it like a function.
Oh, like treat as a parameter or something?
Yeah.
Oh, okay. I'll keep that in
I
mind.
think either works.
Yeah. So, I'll just leave it like that. So, not. Switch. So, it's going to flip the values. So, what's the opposite of true? False. What's the opposite of lava? water?
That's up to interpretation.
Yeah, that's true. Okay. Sorry about that. Left, right, green, red, up to interpretation. So we got lights off, but switch is true, and the only way you can run this code if it's false. So what do we do here? It's true, but it's not true. If it's not true, then we make this value false, and it's going to run through here. All right. So, and then if I do a not again, I don't know if this is going to do it. So let me put it as a function. Jason pointed out to me. So if I were to say not switch, so inside out, true, it's not true, so it's false, but it's not false, then it's true. What is the question? Or what is the answer then? Lights on, awesome, because again, this is true, the opposite of that is false, and the opposite of that is true, but you can just view it as these two nots cancel out. So so if you, I don't know, like for example, you multiply -1 by -1, those are on the opposite side of the spectrum, and you combine it, you get a +1. So there you have it. There's your light switch. So are we good on that?
I think so.
All right, cool. Functions. So you saw me do like everything in this white space. Well, what if I throw in a screwball here and say I do this? So def main. So def main is the main function that Python will look through first. Any other functions will it'll be read, but it's not going to be executed in there first. So I'm going to print out hello world, or hello, I'm in main. And then I'm going to print this one to be I'm number 1. And let's say I want to print out main, right? So if I do that, or hello, I'm in main, great. Now if I were to do the same thing, or I can do it from here too, because the code ran and it's in the shell. So if I also do it here, I'm going to try to print out I'm number 1 using this function call, and that's what it's called. When you refer to a function, like when you call the function, you gotta have the name of the function and the parentheses. If there are parameters inside of it, then let's say, for example, message. I'm gonna make this a message. And so it print out number 1. So what we see here is a function that has no parameter inside of it. But with 1, there is 1 parameter inside of it. So if I were to call that function now, I will need to send a parameter to it, so it needs to match. So again, same deal with shoving squares into circles. It doesn't work like that. Message, it could be anything. I have not restricted to be a string or anything like that, so I could be like, hey, calling from, or calling, or printing from 1 function. And here I go. If I run main right now, it's gonna print out both expressions. Hello, I'm in main, and it's gonna go through. It's gonna see this code and see, oh, 1. Where have I seen this before? Oh, what's this? Oh, there's a function right here called 1, and it takes in a message. What is this message? A parameter is essentially a variable for, in a function. So, or for a function. It's like what you pass in input. So here is my parameter. Here is my message printing from 1 function. If you just replace this message with this value here that I put in for the, the function call, then it's, message, it's going to say like this. It's going to say, in this case, message is equal to printing from one function. That's what it's trying to say. And then it's going to print it. So what's it going to do? It's going to print it, and it's going to say it right here in the shell. So, and then we exit out of the main loop. And the way I've been automatically doing this is that at the end of the code, I just put in main parentheses. So you could do it without having this at the end, but to call it, you gotta say like in here in the shell main parentheses, and it'll do it for you. So as you can see, you have the stuff here. I don't know why it's like that actually, so that's new. Awesome. All right, so without further ado, so let me do some math here. So let's say you got a sum, their total. I can't use sum because this highlighted means is a reserved word. So let's say its result is 1 plus 2. So I'm going to make two functions here. And by the way, the way to make a function is you put in def, which is like definition or define, right? And 2, this is the 2 part, and the 1, the blue part you see in the functions are the names of the function you want to call it. I can be saying brioche buns. It doesn't matter. I could call it bread. I can call it apples. Anything. So in this case, I'm just going to keep it like relatable to what I'm going to do here. I'm going to say 1 and keep it small too. I'm going to make this return 1, and I'm going to make this return 2, not 3. And I'm going to print out the result of 1 and 2. So as you can imagine, just by looking at the names, you can see, oh, 1 plus 2 is equal to 3. That's simple. It's like, well, yeah, that's true. But what it's going to do is going to call each of those functions, go inside of it, and those functions are going to return that value. This took me a while to understand this actually. So yeah, as you can see, it's going to be 1 plus 2 is going to be equal to 3. So 3 is stored into result, the variable result. It's an int, it can tell what kind of variable it should be based on the value. So print the result, which is 3. So what's going to happen here? It's going to it's going to see this, right? I make it run through main. It's going to read this line, and it's going to see 1. Okay, if I can highlight 1, it's going to read. It's going to find 1. It's going to be like, huh, where did I find this function before? Have I seen this before? And it's like, yes, I have. It's at the top of the code. As you can see, it's going to return 1. So this whole function here, it's going to end up saying, it's going to be 1, or I should make this as a comment. So 1 is equal to 1 now. So now it's going to read 2. So this whole function now equals 1. Yeah, I'll just leave it like that. And now it's going to see the next part. Plus 1 plus what? 2. What is 2? Okay, I've seen this function before. Let me go back up here. What is 2? Oh, it's just going to return 2 to me. Okay, great. And then it's going to say 2 is now equal to 2. And now I can replace this with 2. And what happened here? 1 plus 2 is equal to the result. The result is 3 because 1 plus 2 is equal to 3. And it's going to print that out. Okay, great. Now, what if I want to say, change this up a bit. I'm going to say second number. And I'm going to say first. So first and second, I'm just going to refer to the numbers. So I'm just going to combine two numbers together. And I'm just going to say input, enter your first number. And I'm going to say enter your second number. And what I'm going to do here is, and keep in mind you don't have to keep this in one line. So let me just break it up a bit. Okay, I don't know why I did that. Second fave number, Wow, that's a really weird. Second, no. Sec. Return whatever number. You know what? I'll use that. Num2. I'm not even typing well here. Alright. What happened? Oh yeah, I'll fix that. Number. Return number. So we're going to return whatever we put in there. Return. Enter your first number. And gonna fix that. Thank you. Here we go. We're going to call this. We're going to do the same procedure again. First, second, and we're going to run the code now. So enter your first number. Let's say 7. And then oops. What am I doing wrong? Hint. Am I not capturing? Invalid literal for ints with base 10, 7. Oh, did I accidentally input wrong or something? 3, 5. Okay, cool. So as you can see, enter your first number. I guess I put in, I made a mistake inputting 7. So it's gonna go through here, right? First, where is first? Where have I seen this before? In here. This is where I defined it. This is so this is the definition of that function first. So number, what is it? What is it telling me? Oh, what is enter your first number? That's where it asked me, and then I enter my number, and it's gonna return that number. It's 3. So that's what it's gonna return. Enter your second number. Where have I seen second before? So after it tells me 3, this is 3. This whole function here is 3 now because you know that's why I inputted. And plus the second number. Where have I seen the function second? Oh, right here. Number 2. All right. So I put in my second number. I put in 5. So now number 2 is equal to 5. Return that number 5. And now this whole function is now replaced with 5. So what do we got? 3 plus 5 is equal to 8. And that's where we get the 8 from. Awesome. So I can do multiple things here. So as opposed to saying, you know, result is equal to first plus second, I can do add numbers. And I can say A and B. So if you want to have multiple parameters, you would have to put a comma in between to list off your parameters. In this case, I'm going to put 2. So what I'm going to do is I'm going to return A plus B. I'm just going to do it in one line, just, you know, and say like, hey, you can do it like this. So if I run this, well, hold on. I got to make a call to it first. So what I'm going to do is that I'm going to add numbers, and I'm going to say I'm going to say first is this and second is this. These are my two parameters. So here we go. Alright, enter first number. Let's say 8. And then let's say 10. Alright, cool. That's the result. 18. So let's work this out. Inside out. So we got, wait, is that a movie? Yeah, that's a movie. Wow, I accidentally said that. Okay, first. So where have I seen this function before? Okay, up here. So you get the same gist. I put in 8, and that's what it's going to return. So numbers 8, return 8. So first is 8, which makes A 8. Okay, that's a lot of 8s. Alright, so A is now 8. That sounds really close to each other. And then we're going to move on to the second parameter. Second parameter is the same deal as the first one. Or the second function is the same thing as the first one. It's just different numbers. So we got 10 different variables. 10. So it's going to so number 2 is 10, and it's going to return 10. So that's going to be my second number. So it's going to be 8. And so this is 8. First is 8, and second is 10. Now, since we're done with those two functions, we're going to deal with the outer function, add numbers. So what do add numbers take in? They take in two parameters, a and b. A and b are ints, or I hope they are numbers because I add them together like that. I guess you can do it with a string, but to make it easier to explain here, I use numbers. So a right here is this a, and this b is this b. So 8 plus 10, return that value. So this thing is 18. So what do add numbers equal to? This is 18. So this whole thing here is 18. That goes into, result is 18, and print that out, 18. All right, I think we're good for functions, right? Yeah. All right, cool. Loops. All right, so as opposed to saying 10, like the intro to one of Eminem's videos, he's like 10, 9, 3, 2, 1 kind of deal. So like, I don't want to keep doing this. Can you see how slow I am? I am not Speedy Gonzalez. Wow, look at me. I'm on 7, 6. I'm not going to continue doing this. Well, wow. No, actually, here, time me on this. So here, 5, 4, 3. Oh my gosh, here I go, guys. I could copy and paste it, but I didn't thought of it just now, so there I go. All right. So here I am, blast off. So, all right. So if I run this code now, main is not defined. Oh yeah, I left my. No, I'm just gonna keep it. I'm gonna make a def main. I'm gonna keep a function. I'm gonna be like a actual. This is not what I'm used to. Usually in other languages, you would have a main function, and that's where the entry point of your whole code would be. So probably want to make a habit of having a main function as opposed to using this whole entire text editor. So if I run the code now, there you go, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. That took me forever. I wish there's only, I wonder, is there something out there that, not make me do that? So there is. It's called loops. What do loops, can you imagine what a loop does? Yeah, it does like circles like that. So let's just do for I in range 10. This is the syntax. You get the keyword for, and then you get your iterator variable, which pretty much will increment for you unless you specifically want it to decrement. You will do that in the range function. In range 10. So it's going to start from 0 by default, and unless again you specify in range. So in this case, I want to print out I. So here I go, and then at the end I want to say blast off. Wow, only 3 lines of code to do that. Watch this. Wow. Wait, I did it backwards, but that's okay. Also keep note, it starts from 0, ends at 9, so this number is not inclusive. In other words, it will not print out 10. So if I were to do 11, it should start from 0 and end at 10 and blast off. So if I want to mess around with this function, this range function, I want to start from 10, end at 1, and I want to go backwards. So you put -1 to step down. So the first parameter is the initial value, the second one is the end, and the third one is the steps. So if I want to go down like by 2s, by 3s, by 4s, by 5s, etc., you can. In this case, I just want to decrease by 1. So to do like what I did before, as opposed to, oops, I also forgot, this is also non-inclusive. So if I were to repeat what I did in the beginning before I knew about for loops, this is what this is what it will do. It does the same thing like I did in the beginning. I was not paying attention to what I said like a few seconds ago, so I probably messed up there, sorry. Anyway, all All right, for loops. There it is. Great. And that's for loops. I totally know. I know I'm gonna miss a lot there. So let's say is there a different type of loop that you can do? Yeah, I can. It's called a while loop. So I can do the same thing. I can say let's say number, right? So number, and let me comment this out. No, actually I'll leave it like that. So, and I'll print a separate, like, so how are we on the time?
Hour and a half.
Hour and
40 minutes actually.
Hour and 40 minutes, really? Wow. Okay, print, and then
Well, around there.
with while.
This is based on the estimation that you started at 9.
Oh, with while loop. So that was it /n? That's a special keyword to say new line. So what it's going to do, it's going to say, for example, with this code, it's going to say blast off in the shell, right? From that for loop. At the end of the for loop, I have print blast off. So what's it going to do? It's going to skip a line, right? Leave that white space, and it's going to give me with while loop. And then it's going to give me a skip there and a new line, and I can continue doing while loop things. So doing the while loop things. So the difference between a while loop and for loop, so for loop, it has an increment, an iterator that increments or decrements automatically, whereas a while loop, it will continue until this condition is false. So in this case, so if num is less than 1, so if num is 0, then break out of this loop that you're in. So if I want to say start num with 10, right, and I want to say print num and decrement, that's important, because the thing is I can do minus equal 1, right? And then I'm going to say print blast off. Again. Team Rocket blasting off again. Alright, so you got num equal 10. 10 is, oh wait, wow, I'm an idiot. So make sure this while will execute as long as this condition is true. So like the if statement, but imagine it keeps going back to that if statement until it's false. So is 10 greater than 1? That's true. Go through here, print that number, then decrease that number by 1. So that way we don't get stuck in this loop forever. Because if I were to get rid of this and run it, as you can see, it's going to continuously say 10. I'll never change that value. You need to change that value. So here, I'm going to do it here while it's doing the infinite loop. So if I do it now, so here we go. If statement, this is the for loop. Now it gives me that space, and then with the while loop, print this out and the space. It's going to start off with 10. 10 is greater than 1, so it's going to run through here, and it's going to print it out, as you can see here, 10. Decrease that by 1, and what is 10 minus 1? It's 9. So here you go. Then it goes back up. Is 9 greater than 1? Yes, it is. So print it out, 9. Decrease it by 1, 8, etc. Go all the way down to 2. 2 minus 1 is 1. Is 1 greater than 1? No, it's not. So it needs to break out, and now it will say blast off again. So if I want to do like what I did before, I could do it's greater than 0, run it. Same thing as a for loop. I was just off by 1 number. So there you go. For loop. While loop. Can you spot the difference? You can't, because I just added in again, so nothing new. Alright, cool. So alright, let me just actually try to take this off a bit. All right, cool. Okay, so all right, so this is the while loop, this is the for loop. You can tell because of you know, the keywords you use, and plus how it's what it looks like. So you got an iterator, you got something that, you know, that can increment or decrement. So if I were to reverse this, so I can do from 0 to 11, because if I remember correctly, the last number is not involved. So let's say I want to count by 2s. So I do that, right? And I'm just going to get rid of this blast off. And here I can do the same thing here. So plus equals 2. I'm just going to keep I'm going to go back and forth and show like the translation between the two loops. So there we go. Let me also say like which one is which here. So with 4, awesome. So with for loop, you got this, and with while loop, you got this. So let me bring these two together. All right. So I'm going to count by 2s, and I'll go and count up all the way to 12. Let me make this 13 because it doesn't include 12. Also make this 13. So let's do this. Cross fingers. All right, awesome. With the for loop, 0, 2, 4, 6, 8, 10, 12. With the while loop, 0, 2, 4, 6, 8, 10, 12. Great. See, that's the difference. Also, one of the things with the, you know, one of the main differences, in case you don't know, or you would use a for loop to, if you know, usually if you know how long it would last, you would use a while loop for something that you don't know how long it will last. So let's see if I can come up with an example of that. I don't know, but can't really come up with an example because you can translate. The other one's probably a little bit more work with the for to do something like that for the while. But let's say I want to print out my name letter by letter. I mean, yeah, character by character. So my name is Andre. And then you get the range, right? How do I get the length? Well, I mean, I guess I just gave away the answer, but like, so to get the length of a variable, you use this keyword called len, which is the first 3 words of length. So you see it highlighted, that means you're on the right track. I can do it here too. Length of name. And if I run this code now, so automatically I will be a string because this is not a number, and we are not doing like 0 through 10, 10 down to 0. We're not counting from 100. We're not counting to 1000 by 10s. So here, let me increase this by 1. And so what I'm going to do is also name. This is going to be special, right? Arrays. I'm just going to do a quick overall of arrays. Frick, that's also a thing I need to introduce. So with the for loop, you got that. So let's just give it a shot to see what we can get. All right, cool. For loop zeros, numbers. Forgot to refer to that. So what I did is okay, so let me explain here. So name is an array of characters, right? So what is this equal to? It is equal to A plus N plus D, and you get it, right? RE. So to access those individual characters, I would have to index that string. And what it kind of means is like, you know, just getting that single element in that list or in that array. So we got a string of characters, ANDRE. If I want to get, and it starts off from the 0, so this A is 0, N is 1, 2, 3, 4. So again, if you have, you know, 8 slices of pizza, you are technically correct if you say there are actually 7. Computers count like that, where the very first element is actually 0. So for I in the range of the length of my name, so in this case it will be 5. So it'll say starting from 0, I is 0, go through print, get the 0th indexed of the variable name. What is the 0th or the very first character you see in my name? I give you a clue. It's highlighted. It's A. So I didn't, here, let me run that again so you can see it. Oops, forgot I need to get rid of that. Here, let me just comment that actually. So there we go. So the very first, which is 0, part of my name is A. Alright, so it's going to print out A. Then it's going to increment automatically, because this is what an iterator does automatically. Increment or decrement. And it's going to be now 1 after it ran this code and printed out my A, not my actual A. So now it's going to be 1. What is the first, or in other words, what is the second character in my name? It's going to be an N, and it's going to keep looping. 2, 3, 4, 5. Well, yeah, the length is 5, so again, 0 is 1, 1 is 2, you know, you count, you're starting from 0, so it's 5 in total. So now we move down to the while loop. As you can see, we got an identical print statement here, so same deal. Num starts at 0. We have to put that in because the while loop does not have an iterator that automatically would, you know, change the number by itself every time it runs through the loop. So we got num is less than 5, which is true. It's 0. Go ahead, give me the 0th index of my name. It's Andre, so it's A. You got the A from there. That's the 0th part. So it's going to print out A. And then we want to increase that number 1. So this number now is going to be 1, but we don't see it because, you know, this is just the starting. This is me initializing the number, my iterator. So so we're going to increase this by 1. Num is now 1. It's less than 5. Give me the first element, or I mean in this case the second element in my name. It's going to be N, and then we're going to increase it to 2. Go back again. 2 is less than 5. What is name index or subscript 2? It'll be D, because 0, 1, 2. Awesome. Alright, so what else? Are we good on that? Here, let me do a fun little side project here. So like, let's say you're given the question, find x. You're doing basic algebra, right? Algebra 1, one step equations, right? So you just got to move the variable over, and you just do you just find the variable, you know, the one step, just take it over, the one step equation. So you get questions like x plus 2 is equal to 4, what is x? Or stuff like y minus 5, 4 or 5 is equal to 8, what is y? That kind of deal, etc. Well, what if you're lazy? You don't want to do that, it's too much work. What you can do is, so you get x, let's say x, and where was I going with this? Never mind. And what I'm going to do is wow, okay, I'm sorry, I dozed off a bit. So let's try to figure out x, right? So x plus 2 is equal to 4, right? So we're trying to figure out what is x. So we're going to start off x with 0, and we're gonna run and figure out what is x. So if x is okay, no, hold on. We're going to do it this way. If x plus 2 is not equal to 4, then run this while loop. And we're going to increment this x by 1. And I know I did that multiple times, but let me do a translation there. So it takes, so x plus equal 1 is essentially x, it's pretty much x plus 1, and then it just saves the value to itself. So we're just saving an extra step there. Or not an extra step, but just, I don't know, it's just a way some people like to say, like, oh, I just want to increment it by 1. I don't want to write out x is equal to itself plus 1. So, but that's what it translates to. So, so we're going to increment x by 1, and then it's going to print out the answer once it disproves that. So x, so here, x equals, let me put a space there, plus string, casting that int to a string. Hopefully you remember that from the beginning of this video. X is equal to 2. No way. What if I want to say 19, right? So that's going to be 12, right? So like if I do it again, wow, I'm really lazy. I can do my one-step equation. You know, that kind of deal. So what if I do like, let's say 123, and let's see, and 1. So it's going to be 122. Dang, I'm lazy. I don't know how to do math. Anyway, it probably won't work if I do negative, but let's see, like -1. Yeah, and then I don't know how to differentiate that, but like, let's say 90. I'm gonna make this starting off from 100. I make an educated guess, and I'm just gonna say like, oh, let me start from 100. Oh, I probably messed up. Yeah, it's probably infinite loop. That's why it's not printing. Oh, wait, why did I do it again? Okay. You know what? I'll increment. Oh wait, that's right, because it was 100, and it's keep adding 1 to it. So, all right. So the answer is 91. So, wow, great. So what if I do -5? Then I would have to change the number there. So let me do it that way. Awesome. So x will be -4. See, you can do your one steps like that. Ain't that cool? All right. Functions. Oh, I already did functions. What I forgot to check off there. I guess I can't do tabs. Oh boy, classes. Oh boy, classes. What are we on the time?
2 hours.
2 hours?
Wait. Yeah, 2 hours.
Oh man, really? Oh no, actually we've been on for 1 hour and 45.
Oh, so
awesome.
We started at 9:15.
Awesome. Okay, so okay, let me I don't know why I did that. Alright, wow, I'm actually really speedrunning this. Classes. So classes are essentially blueprints. So like, what kind of car? Do you like cars? Do you like Hot Wheels? I like Hot Wheels. Do any of you guys still collect Hot Wheels? So like, each Hot Wheel. Here, I'll do a Hot Wheel example actually. Each Hot Wheel has what?
Is an individual car called a Hot Wheel? Or is it still a Hot Wheels?
There are more than one wheel.
Exactly.
Oh boy. Okay, so this is the kind of question you want to ask yourself. Each Hot Wheel car has what? That's right, a car. I mean a wheel. It has, each cars have wheels, right? They all have a body type. They have a color. They have a spoiler. They have seats. How many seats are there? How many wheels? We already got that. So you get the idea. Like, what do they all have in common? And without having to say like, oh, Hot Wheel car 1 length, wheels is 4 or 5, and then car 2 wheels is also, it's like 3. It's like a tri-car, and then you have to like, okay, then you have car 1. Let's see, color is red. Car 2, you know that, you get the idea. Like, you don't want to like make, like, let's see, so if you want to make 2 cars and you do like what I try to do there, and you have all these attributes or features that this car has, that's 5 features, two cars, that is 10 variables. 10 variables. So we got like 5 features here. So 5 features times 2 cars. 2 cars there, right? That's 10 variables. I don't want to type all 10 variables. I mean, at least I want to give them like a default value once. I mean, sure, I'll accept that both those cars, like, let's say you work for a company and they got the factory, they do the whole assembly line, they just make like all these generic gray cars. So here, let me start typing this up. So this is the, okay, I apologize for that. So this is the syntax for the creating a class. You got the type class and Hot Wheel. I don't think you need parentheses next to the name and the colon, right? No, okay. And then here I go. So what kind of what do they have? How many number of wheels? So let's say number of wheels is equal to 4. Color is equal to be gray. Doesn't, or gray or with an A or an E. Spoilers, do they have it? Yes. So yes is true. They do have a spoiler. Seats, how many seats? Let's see, 2. And body type, I don't know. Slender. Awesome. So so there's your class right there, except we're missing something. How do we make an actual object of this class? So is it like that? Yeah. No, is it? Yeah, double underscore colon, and this needs to be a function. So this is a special function. You can't make it up. And what it is a constructor. So what it does, it makes an instance, the actual generic car, out of this class. So we got, if I want to make a default, I'll leave it like that. Self in this parameter is just referring to the object that you're making right now. So if I were to make Hot Wheels right now, so hot wheel. So there's my class name, and in order to make an object, I will say car, or let's see, what's a cool car? I don't know. I like Mustangs, or I'm just familiar with them, and that's how I do it, right? Mustangs. There we go. And then let's print out Mustangs. Color. So what's the color of this Mustang? I'm missing syntax. Okay. That's not the right syntax. Frick, what was it again? Hot wheel class. You got, what was I missing?
Did you ask what I was missing?
Yeah, like what am I missing? I got the syntax error here.
You don't put types in Python.
Really? Oh, okay. Then how do I create a Hot Wheel?
By calling the constructor equals hot wheel
Oh,
or new hot wheel.
hot. Is it Hot Wheel like that?
Yeah.
All right, cool. Okay, so that's how you create an object then. So if I run this now, it has no attribute color. Oh wait, Mustang's color. What's going on? Is it self? Oh,
Need to be defined outside of the constructor, dude.
color.
Those are local to the constructor.
Oh, true. Okay, let me fix that. So to define it, I can just do it like this, right? They're probably gonna bark at me for that, right? If I do it like that, I'm just used to the self dot because that's the right way to do it, right?
Yeah, try the self dot.
Alright, so sorry about that. That's gonna slow me down. That's like 5 minutes off my speed run. So this object's numbers of wheels is gonna be 4. This object's color is gonna be gray. This object's spoiler is true, so he does have a spoiler. This car's seats, and you get the idea, like it's referring to the object that's being created right now. And if I run this code right now, it's gonna be gray because so we made a new object of Hot Wheels, and you know it will have all these attributes. So we test out with gray, right? And then we print the color. So to refer to the color, to do a Pythonic way, you just type in dot. So if you think about it this way, actually, Mustangs replace self here. And then you got this period, right? So you're following the formula here, and you get color. And what is that color? It's gray. Awesome. So if I do the same thing here, so like, let's see, BMW is equal to Hot Wheel, and then print BMW seats. So if we follow the formula that I just mentioned now, like you get the name, replace it with self, you can see it that way. I guess I just came up with it on the spot. Period, seats, and what's it gonna print out? And you can take a guess. It's gonna print out 2. Well, and then also got gray from the Mustang part. Awesome. So that's a Pythonic way of doing it. So you won't see that really in that much in like C++, right? Yeah. So what you would usually do or what you could do is get a setter function, getter function. So get color, and what this would do, it will return self color. And let's say we're going to get number of wheels, get number of wheels. And what's this going to do? It's going to return how many wheels I have. So number of wheels. Awesome. And then so what I'm going to do is I'm going to see, I'm going to make a comparison. If I got to make two objects. Two objects are the instances of the car. So let's say you got a car 1, red car is equal to hot wheel, and then blue car is equal to hot wheel. No, actually I should just make it car 1, 2. Makes it more, because we're dealing with generic car constructor. So if car 1 get number of wheels is the same, if it has the same number of tires as car 2 get number of wheels, then you can say like they both have the same number of tires, else they don't have the same number of tires or wheels. I forgot my colon at the end of this if statement here, this long if statement. So there we go. So if we run this now, oops, forgot my semicolon up there. Run this now, has no attribute to that. Give me a sec. Hot Wheels, car 1, car 2, get number of wheels. There's no S. Make sure the function names are the same. So if I run this now, it takes in 0, but 1 is given. Oh, okay, so I forgot, in the class, when you have a function, actually when you see a function inside a class, that's a method. When you see like a variable inside a class, that's called property or something else. I don't know what it was, but so I don't know, this is like a Python thing where you gotta like refer to yourself when you make these functions. So each of these functions take in a single parameter called self, which refers to yourself, to the object. So they both have the same number of tires. So car 1 is an object of this class. It just got out from the factory. Nothing new, no paint, nothing. Just it just has 4 tires. It's gray, it's slender, it has 2 seats, and it has a spoiler. So it has 4. So what it does is, like, I made it an object from this class. Call in dot, because that's how you access these functions if it's an object of a class. And get number of wheels, right? So where do I see this function before? Oh, up here. Awesome. So I want to return the number of wheels that I have. So it's going to refer to this first car here. So car 1 period number of wheels. Number of wheels is 4. Awesome. So it's going to return 4. So this whole thing is 4. Check on the other side. This car 2 came out from the same factory as the car 1. So it also has 4 wheels. It sees this method or this function that car 2 is trying to call by using this dot. Car 2 dot this function, get number of wheels. Where have I seen this function before? Up here inside the class. self dot number of wheels. Where did I see number of wheels before? Self number of wheels up here in the constructor. It's 4. I have 4 wheels, so it's going to come back here and say, oh, I return 4. So this whole function is 4. So this whole thing is 4. So 4 is the same as 4. So it runs this if statement. So there we go. Else, if not, then you know, they don't have the same number of tires, which I'll get to next. So if def, okay, so I'm going to set the number of wheel. So it's going to be self number, and I'm going to set self number of wheels to be equal to whatever the number that we put in there. So alright, awesome. So let's say we want to pimp my car, right? So pimp my car to have 3 wheels, right? And we're going to make it car1 set number. We're going to access the functions inside the class. That's where we belong, because we are part of that class. We were part of that factory, so we have access to all the benefits that are in that factory. So set number of wheel, and I'm going to say 3. Remember, so it looks tricky here. So as you can see, there are 2 parameters here. I only put in 1. Self again refers to the car itself. I don't know why Python did it this way. It's just Python. And 3 is referring to the number here. So self again refers to the object, and 3 is referring to the number. I don't know. Our functions are variables defaulted to private or public. I'm not sure. Is it? Seems more like public, right?
I don't think variables in Python even have a...
They don't have like a modifier, accessor modifier.
Yeah.
Yeah. I mean, there isn't really any.
Verify that real quick.
Yeah. Jason can verify that to make sure I'm not lying to you or anything. Just double checking. To me, it seems like it could be. They're more like public. So. But we'll find out shortly, hopefully. And so
Python does not have access modifiers.
Yeah.
It's always public.
Okay, so the verdict is Python does not have accessor modifiers, so it's always going to be public. So it's defaulted to public. So rewind a little bit. Self is the car, the actual object of this class. And then the number is the actual number that you put in, that you input here, so 3. So if I were to run this now, following the same process like in the previous run, this will return 3 because we overwrite this, we overwrote the variable, the property, number of wheels to the number that we put in. In this case, we made 3. And then car2, we didn't make any changes to it. So, here we go. We're gonna run this. Alright, so pimp my car to have 3 wheels. They don't have the same number of tires. Awesome, so it works. Yeah, it defaults to public. I'm just trying to like introduce like the concept of getters and setters in like other languages, because we won't have really the luxury of like what Python provides in like C++ or C or Java. I don't know really much about Java, but Jason does. So I took a semester of Java and I totally forgot like everything from that class. So yeah. So yeah, I'm just making a habit of like trying not to do Pythonic ways of doing things. So like for example, Python has that for I in range 10. In in other languages you would have like like what you might see like for int I is equal to 0, set the condition, and then you increment. Whereas Python kind of does that for you. Also depends on like what you put in the for. So we're gonna, what else are we gonna do here? Body type. We have all these properties I haven't used. So we're gonna get color. You know what? I can make a new function too. So here, I'm gonna make a print all. I'm gonna make use of the remaining properties that I haven't used. So if I just want to get information about, you know, the car, I can do, you know, here's the info. I'm just gonna do with one car. So let's see, we got number of wheels is gonna be, I'm gonna cast it to a string, and it's gonna be self number of wheels. Color of the car is gonna be the color that we already have in the constructor. So it's gonna be, it's already a string, so I'm gonna do self.color. Remember to match the data types. And then does it have a spoiler? Has spoiler. I'm gonna say, oh yeah, here, let me make an if statement here. If it does have a spoiler, then if self spoiler, then print, oops, forgot my colon, where's my, okay, and print has spoilers. Else, let me keep forgetting my colon. Else has no spoilers. And let's see, seats, gotta get the seats. Number of seats would be print number of seats. And the good thing about this is, like, I only need to write this once, and I can just have each object to you know, refer to this print, and I don't have to write out this whole function again for each object. Like if I were to go back in time and do like what I did before, trying to like make car 1 length, car 2 length, and then, you know, repeat for each attribute, I wouldn't have to go through. I mean, I could make a function actually. Yeah, never mind, actually I can do that. Oops, I hard-coded that, my bad. Here, let me self.seats, and that's a capital S. I was not consistent in that. So let's see, print dot body type is gonna be, it's gonna be the value. Let's see, and it's gonna be self dot body type because it's already a string. So there we go. That sums it right there. Let's see, get that. Okay, we're gonna put another set because I want to like mix it up a bit, you know. Set number, not number. Let's see, set number of seats. So again, same deal with number of wheel. The object that calls that function is the actual self in that parameter, and we're going to change seats. So I'm going to put another number there, and I'm going to say number, oops, this is going to be seats. Sears. Wow, I actually spell Sears. T is going to be number, and let's say we want to change, and here, let me get rid of this. And let me move that more over here. And let's say I want to print out, I want to know information about car 1's deal. So car 1 dot, that almost looks like Carl actually. Carl, that kills people. Anyway, so we got car 2. We're going to set number of seats. So pimp car 2 seats, and we're going to say 4. You know, the normal 4-door, not 4-door. Oh, why didn't I make that as a attribute? So car 2 dot set number of seats. We got 4. We're going to say car 2 print all, and let's say car 2 also. We're going to set set number of wheel to be 5, in case, you know, you got a broken tire or something. You can always like replace it on the interstate or something. And let's move this away so we can see the text better. So pimp my car to have 3 wheels. So this first info refers to the first car. So as you can see, Carl, or car 1, set number of wheel is 3, right? So, and we're going to print out all the features in there. So car 1 is going to be this self, right? And we're going to say dot print all. So dot print all. Where do I see this function before? Up here. And we have this, you know, chunk of code here that is pretty much a series of print statements, except for the middle part where we check to see if it has spoilers or not. Hello, welcome to the stream. And we check to see if it has spoilers. If it does, it goes through this line of code because it's true. It does have spoilers. If not, it has no spoilers. It goes to the else. And then number of seats refers to the number of seats. Body type, it has a body type. And we make sure that they have the same data type. So I should probably separate this a bit. So let me make it easier to read. So let's see, car 2's information, or car 2's info. I'll also add a new line so that way we can separate the text, make it more readable, as opposed to seeing, like, you know, the end of car 1's attributes and the beginning of car 2's attribute list right there. So car 2's attribute, and then let's see, or actually here, let me change this a bit, get rid of that info, and then I'll put this, that way I have control of, you know, saying info here. So alright, so pimp my ride to have 3 wheels, that's a clear indicator right there. Let's see, car 1's info, and let's see, we're going to do it like this. Oops, I forgot to end my print statement there. Alright, do that, run the code. It should be prettier. Good. So in the beginning, we made 2 cars and from the same factory, same class. And car 1, set the number of wheels to be 3. As we can see that change right there. And we're going to print out the car's info, which happens to be in that same group of output that we see there. So we got car 1's info right there. You got that's where it's from. And then print all shows all the attributes of this car. So we're going to see number of wheels, color is gray, has spoilers, it's true, number of seats is 2, body type, it's slender. Alright, and then car 2's info, we got number of wheels, it's 5 because we want to make sure, if you, in case you break down in the middle of some interstate, you got an extra tire to replace. The color is gray like the previous one because they came from the same factory, same constructor. That's the keyword, like the vocabulary there, I guess, if you like. Has the spoilers, same deal, like the color gray. They both have something in common like that. That's what they both have in common. Number of seats is 4 because we set, that's the new function. So car 2 is an object of Hot Wheel. Set number of seats is a function, or a method in this case. If you want to talk about a function inside a class is a method. So to access that method, you put a dot after the object, and then you say the name of that function. And set number of seats is up here. So self is referring to car 2. Number is how many seats you want, and we're just going to overwrite that self.seats with that number. So here we go. And then we just print it all, and then it's going to print out all the info about that car. So I'm probably not going to go over Pygame, but probably going to do the last thing is inheritance. So let's clear this up a bit. So we got a new model, Hot Wheels. Let's say this is Alpha. And oh yeah, I forgot you can't collapse code. And let's see, we got a new class called Beta. Hot Wheels Beta. Make sure I don't misspell it. Oh, welcome back, Taco. And Mr. TJ, seems like you came in the the right time. So def that we're gonna make a constructor. I gotta make sure they're separated, and there are 2 underscores there. I should not make that as 1. And this is gonna be self, and this is gonna call the super constructor there. So I think I can just do self like that. No, I gotta do like this. And let's say Hot Wheels. This whole time, all these cars, they don't have doors. How did they get inside the car? So they realized that in their alpha version that they didn't have doors to get inside the car. So we're gonna make a new variable, a new property, actually a new attribute, doors. Number of doors. I'm going to shorten up number to be num, and then going to have it doors. And let's say 4. You got your standard 4 number of doors. And let's say I want to also set number of doors, or set doors. Hopefully it's self-explanatory. Self doors, number of doors, num of doors. And we're going to override that number of doors with we're going to set it to the number of doors. And let's see, we're also going to get doors, so that way we can access, we're going to have a setter and getter function, and get doors self, so it's going to refer to the object that's calling this method self, or return that number of doors. So self number of doors. So if so by default we have number of doors to be 4. So we call this function immediately, it will give us 4. So let's make 2 types of cars. We got the alpha car, Alf from Pikmin. We're going to call it Hot Wheel because I just changed the name of the class to be Hot Wheel Alpha. The ones that don't have doors, no door, the no door car, and then we got Beta to be Hot Wheel Beta. 2 different classes, but they do relate to each other. Has doors. How do they relate to each other is by inheritance. So you got, like, imagine this family tree. I mean, everybody has a family tree, and yeah, Unity has C# and also has JavaScript, but a lot of people prefer to use C#. Oh well, and Mr. TJ says it too. And there was this one time where Unity had like this extra language called Boo, but no one really used that. Or nor have I seen any tutorials that had Boo. So, here we are. So okay, back to inheritance. So Hot Wheel Beta is a child of this parent class called Alpha. And so what it is, it's like you got the parent, right? And you know, if you make an object of Hot Wheel Beta, not only that it will have all the doors, it will also have all the properties from the parent class. So not only it has doors, it's not just a door, it has wheels, it has colors, it has spoilers, it has seats, body type. So if I were to print, let's see. Let me actually copy this over. So I wonder, actually this is gonna be a little bit of experiment here. Ooh gosh. Alright. There, much better. Number of doors is going to be equal to self dot number of doors. Excuse me for you know, going off, you know, there, like making this this line of code long. So I'm going to also cast this to a string because you got to be consistent. You got to make sure this one message that you want to say in the print to be the same value. Again, you can't mix a number with a string straight up vanilla like that. You got to make sure you make the number a string, or you got to make sure that the string is a number. But making a string like this sentence here, just a quick review. Casting this to an int will not be a valid conversion. So I'm just going to do experiment. There's two functions called print all. One exists in the parent, one exists in the child. So here we go. So I have beta, Hot Wheel Beta, and has doors. Alpha does not have doors. And again, I call it Alf from like the Pikmin series. I never played the series. Jason has. So here we go. And so two objects, Alf and Beta. And let's see here. Well, I'm missing out in the chat already. Okay. Yeah. Okay. So what do we do? Alf dot print all. Let me actually see what it will look like. And then beta dot print all. And just run the code. Requires a super object will receive Hot Wheel Beta. Quick refresher. Is this is the way to do to call the constructor in the parent class, right, Jason? The super dot initialize?
Yes, I believe so.
Wait, it's not even highlighted. What's up? Give me a second. I'm just going to do a quick search here. Inheritance in Python.
You know what? You can probably just do super and then open close parentheses.
Oh, right. Here, let me double check that. Wait, right. It's what? Python 3. What's Python 3? Come on. Python 3 with the super? Sorry about this. Give me just a short moment here. Initialize. So it uses the name of the parent class. So Hot Wheel Alpha. I think I remember using super when I did the inheritance stream. Yeah, but apparently this is what they did. So let's give it a shot. Hopefully it works. This is a good time to also debug code. Okay, cool. So it works. Also, you know, don't be afraid to see errors. Type error. So it was just like a mix between two different types. Requires a super object but receive a Hot Wheel beta. I'm not sure about that actually. Let's see. Yeah. All right. Let's see here. Sorry about that. So that was a nice experiment. So we got okay, maybe here, let me separate it so make it cleaner. So I'm just going to use the escape character / n to make a new line to separate the two print alls, because I forgot to put a print a separator between. So this top part refers to the alpha version of the Hot Wheel. The bottom part refers to the beta version of the Hot Wheel. So as you can tell, or as you can see, there are two print all functions, one from alpha, one from beta version, one from the parent, one from the child class. So the child class being the beta, so this is like new version of Hot Wheels. The top part is alpha, the old version of Hot Wheels. So in alpha, the main difference between the two is you can see like beta has the number of doors, whereas alpha, none of the cars that came out of the factory had doors. So and beta, they do. There's doors. We just added that in. That's pretty much going to be our main feature that, you know, separates between the two classes. But beta, again, is going to be a child of alpha. So what it does when I created a beta Hot Wheels was, as you can see, it this top portion here of beta matches with all the attributes here in alpha. So what happened was I called the parent class constructor. So that means I go all the way up here. And let me ask you a question again that I've been saying this multiple times. Have I seen this function somewhere? Yes, I have. In this class, Hot Wheel Alpha, yes, I have. So we go up to Hot Wheel Alpha, and right underneath it, the constructor, we see initialize, or that's what that's why I imagine what init, you know, stands for, NINT. So here we go, and as you can see, all these attributes, you know, are matched up here because that's the alpha object, and this is the beta object. So this matches with, you know, what's there in the alpha, the parent class. So okay, what's next in the line? If I do alpha print all, it's going to look inside the alpha, the parent class, the parent class's print all function. So we're going to go back to the alpha, the parent class, and we're going to look again and see, have we seen print all before? And yes, and here it is. I'm highlighting it right now, and it's going to print out everything that's in this function. For beta, which is part of the beta class, we got beta.printAll, right? And print all, where have we seen this class? I mean, this function in the beta class. Is there a print all in the beta class? Yes, there is. Where have I seen this function before? Oh, right here at the bottom of the class. And what's the difference between the one in the alpha and the beta? Is that last print statement that says number of doors, where I just highlight right there, that line right there. Let me just move it over here. where I just have numbered doors to be string casting. We're going to take this number and we're going to convert it to a string so it can agree with the number of doors there. So there you have it. So you can pretty much do anything really. You can just set the number of doors, get number of doors. Here, I can do that quickly. So we're just going to ignore alpha for now. We know that beta is a child of alpha. Beta has everything from alpha, but it also includes doors. So if I were to change the number of doors, let's say right now, exchange, add in, or no, take away doors, or pimp my doors to be two-door car. Pimp my doors to be a two-door car, and here we go. And beta.print all. Before we print out all the information about that car, we're gonna make beta. We're gonna set the, let's see, what's the name of the function again? Set doors to be a two-door. Wow, I'm defeated right now. Oh my gosh, a two-door car. A two-door car. All right, there you go. I said it fluently now. I can speak the language. All right, here we go. And so set doors, and here we go. And to double check to see if it is a two-door car, print beta dot get car. So we're going to actually make use of the getter function. So let's see here. Yep, let's go and do that. Wait, is doors or door? Yeah, all right, cool. I was consistent there. So there we go. So we got beta.setDoors, pimp my doors to be two-door car, double check to see if it is a two-door car. So it should print out in the second print statement 2, and then it's going to print out all the attributes. And here we go. Number of doors is 2. Pimp my door to be 2, a two-door car. And as you can see, right underneath that statement, you see the number 2. So we were double checking there. And then, wow, that enunciation. Wow, am I not talking right now? Okay, number of doors is now 2. As you can see from the previous run, it was 4, but now we changed it to 2. And we can do the same. Since it's a child of this parent class, we can change all the attributes there. So we're going to change, let's see, the number of seats. So let's make it a 3-seater. So let me get rid of this. And I'm going to say beta dot set, what is it? Seats? Number of seats, all right? Number of seats. And I'm going to set this to be 3. So you got this one big couch in the back, behind the driver and the co-pilot, or the co-driver. So here we go. Up, number of seats. Oh, attribute error. It has no attribute to that. It's not number of seats. Passenger. Okay. This is not co-driver. Number of seats. Number of seats. Am I not allowed to access the functions in the parent class? Okay. Let me see. I can just. No, there has to be a way to access that function from the child class, right?
What?
If there's a function, is there a method inside parent class? Can you access it from the child class?
You should just be able to call it.
Yeah.
That's generally how inheritance works.
Oh wait, did I Number of seats. Number of seats. Let me just copy and paste that. Just double check that I didn't misspell it. I probably did. Let me see. Or here, let me. Okay. Co-driver. Let's see. Number of seats. Everything's fine. Spelled correctly. Number of seats. Hot wheel dot has no attribute set. Oh wait. Does it only inherit the default constructor in this case? I don't know. That's weird. Oh wait. Do I have to let me do a little experiment here. So let's see. Get number, set number of seats, my bad. Set number, wait, I already have it copied, so set number of seats, self number, and it's gonna be self, wait, nope, hot wheel alpha, and I guess I'm gonna have to refer to that seats. Number. I wonder if this would work. Yeah, it did work. So I guess what I did was I call the parent class, and then I access the function, the method, number of seats, and I just pass in the parameter there. But shouldn't I be able to just like call the function from the child class? But okay, if anybody happens to know, please tell me, or Jason, if you happen to know, because like what I did was here, let me just move this over. I made a new function in Hot Wheels beta, set number of seats, and I just call in the function that method from the parent class.
I don't think you have to pass in self.
Really?
It might be implicit. I'm not sure.
You think Python can? You think Python can deduce? Yeah, it's missing self. That's weird. I don't know. I guess I got to take a look at my previous stream to see like how I did it. I guess I have to educate myself again about that. Let's see, what else? Am I missing anything else? Yeah. So how am I on the time? Oh wow. Well, I failed at doing the speed run. Great. It's 2 hours and 37 minutes, and here I am, just like, oh yeah, I'll do this like under 2 hours. Darn it. Great. Now Trevor and Alberto won't be able to watch it. Okay, what is it? So beta dot set number of seats instead of set number of seats, if I'm following. So I did beta dot set number of seats. Yeah. But it also takes in a parameter, so gotta update the number of seats. So like you throw away the fourth seat out. Okay, I'm sorry. I didn't see it. Okay, someone on the app Whisper asked in my ear if someone wants to roleplay. Wow, Taco. Jeez. Okay, but anyway, back to Sir Nick DeSalty. You did beta dot set number of seats instead of beta dot set number of seats. If I'm following, this case is. Oh. Was that it? Oh wait, no, they're both lowercase s though. Where do you see like, oh, you just did, oh, really? Did I do that before? I didn't know. Where do you see that? Do I still have it up, or if I still have it up, it'll probably throw me like an error. Oh, okay. All right. So if I just comment this out, you think it's gonna? Let's see. Set number of seats. Hot Wheels has no attribute to that. Set number of seats. Okay. All right. I think what we did here was we just only restricted calling the constructor, and what we did here was we specifically ask or call the set number of seats in the alpha class, the parent class. So, do you have the thick crusty? I believe I don't have the thick crusty. All right. So, anything else, Jason? Am I missing out here? Like any concepts? Anyways, I guess that pretty much ends here. Wow, I can now put the final X. I guess that's about it. If you guys have any more questions, I'll stay, right now. I guess it's going to be like a Q&A session. Or, I can end it now, and you guys, if you have any more questions, there's Discord. You can follow right there. You just click on the link below. I actually made it so where I can make it clickable, unlike last time in the previous streams where I just say click on the link below and it doesn't click, and it's just actually like a link, and you just actually had to put the extra work of like copying and pasting it to the browser or the URL. So if anybody has any more questions, or if you want to follow along to see what we do, I mean, we got some, let's see. I mean, yeah, we can. Okay, I don't have my Discord up right now, but I'll do it right now. But if you guys have any more questions about Python, either beyond the scope, because what I did essentially is just talk about variables, user input, conditionals, that simple stuff. If you guys already have experience with programming, functions, loops, classes, I pretty much ended it in object-oriented programming. So if you guys again want to talk more about Python or any other programming languages, we know a little bit of C#, only in like Unity. But we did a little not so long ago, we did socket programming in C#, and that was an experience. One of the people, regulars, he made his own client, and it was pretty cool. Like we were able to talk to each other and stuff. Cool. That was so cool. He did his in F#. We did ours in C#. If you guys want to make it in Java or something, or whatever language you want to do it in, we can like communicate with each other through this like really rough chat room. I don't know, it's just a little joke, but yeah, I mean, later in the future, whenever I guess, because we're in school right now, so if I get more homeworks from my game design teacher, I can probably stream that. So maybe if somebody who knows about Unity, game design, or programming, can help me out, we can design things together, make proofs of concepts together, essentially. So go ahead, follow. Follow in Discord, but if anybody else have anything to say, any last things to say. Any questions, actually? I mean, this is pretty much like, so in the past I made like eight streams of these, so it's like 2 hours. Like I would go over like 2 hours, or we would go over 2 hours about loops, over 2 hours about functions, conditionals, and stuff like that to make it really, to really get it to you guys and like make sure you understand it. So yeah, well, that's about it. Oh, and camel cases? Oh yeah. Like, yeah, I noticed like when I did snake cases, yeah. Oh, okay. Yeah. Yeah, I'm used to the camel case. I know people talk about the snake case or something with the underscores. Yeah. Yep, I knew it. They're gonna refer to that. I don't know. Python, I'm kind of also refreshing myself with Python. I'm more like a C++ kind of guy. Like I'm more comfortable with that, and I'm just used to using camel case all the time. So please excuse me with the whole like messing up. I know I kind of agree with a little bit, like how it's all like messed up a bit with all the camel case and how it's not really consistent with the names. Like, so for example, I have like a capital P here. I don't have the snake case, but I have, well, I mean, the constructor, they require the underscores, but I got camel case going on here with a mixture of a, snake case. So yeah, but thank you for sending me the link. I'll take a look at that right now, actually. Pep 8. But yeah, any more comments, complaints, thoughts, fantasies? Yeah, but I'm just doing this like a tutorial for friends or anybody out there who needs, private method starts with, oh wait, there are privates and publics.
They're not real.
Oh well, they're not. They're not real accessor modifiers. So Sir Nick the Sky. So what happened was. So what we have here is. We were asking why it didn't work. So what happened was, this function, as you can see, has no attribute of set number of seats. So it does not have that kind of power. So the child class did not have that power, and or that has that control. So we didn't have control of setting a number of seats. So it would be saying like if I were to do this like random method or random function call, and obviously if I were to say okay, beta is a child, not a child, the object of the class, the hot wheel beta, and we want to call this function. Where have I seen this function before? I don't see it anywhere, so it's going to give me that error. So what I did to fix it was I called the parent class, and then I refer to, like, I call the set number of seats from the parent class. So, and I just pass in the numbers to make it look like, I'm actually changing the seats. Yeah, no problem. Yeah, it's just there. So like, if I run this right now, it's gonna bark at me for saying, where does random function call? It does not exist in beta. Yep, there it is. So let me spread that out a bit. So attribute error, hot wheel beta does not have random function call. Function call. Man, I'm not talking straight here or something, man. All right, so you got it. Alrighty, so okay, right. So we got any more questions, concerns, complaints? Oh, okay. Yeah, that's no problem. Yeah, it happened to me earlier today. When you try to do like a tutorial in like 2x speed on YouTube, I just like miss a step and I'm like, wait, where did I get this error? Or, man, how come I didn't get this right or something like that? And I had to like, scan the whole video and like normal speed or something, or just like randomly pick an area where I think I messed up kind of deal. Yeah. All right. So, are we all good? Are we okay? We got concerns, complaints, fantasies, comments, questions. I'll give you guys some time because I know about the delay in Twitch, that kind of deal. So are we all good? I guess. So again, if you want updates, it's easier for me to say in Discord. I mean, you can go ahead and y'all can ask like, when's the next stream? We plan to probably do it on Sunday. If we're going to do it tomorrow, I mean, we'll let people in Discord know about it. So there's the Discord link down below. It's not that far. I don't really have much on the channel, so it's not that hard to find it. So you can actually click on the link. Earlier, before, I just have it to where it's just like just a text, so you have to put in the extra work to copy and paste, but no longer, because I actually look up on Markdown by Twitch and coded, air quotes, quoted that to make it a clickable link. So alrighty guys, have a safe night. See you guys later. Hope you enjoyed this stream. I guess I failed to do the whole like speedrunning thing, but alrighty then. So again, have a good night. I'll see you guys on Sunday. If not, Saturday, I guess tomorrow. Depends on the see how things go. Alright. Good night.